Let's try to go ahead now and complete example number 8. We're going to have the same exact task that we did in example 7 in the last video, and we're still going to be using this closed interval method. We want to try to find the absolute extrema, the absolute min, the absolute max, of this function on the interval from -1 to 1. All right, so the first thing that we need to note is that we are working on a closed interval, but we need to see if we actually have a continuous function here. So let's go ahead and actually take note of what we have. Now, it seems like plugging in any positive number in for x would never matter in these powers. But plugging in 0 also wouldn't matter. But what about plugging in negatives? Because notice that like this piece right here is really a -3 cubed root of x. Is it okay to plug a negative number inside of a cubed root? Well, actually, yeah, that's totally fine. Remember, if someone asks you something like, what's the cube root of -1, they're asking, what number can you multiply 3 times in a row to make -1? And of course, my answer here would be -1, because notice that -1 times -1 times -1 is -1. So this is what I end up with. It's actually totally fine in odd indexed roots to plug in negative values. And so I actually don't seem to have any problems here with this particular function and the x's that I'm working with. So I'll say that f of x is continuous on the interval from -1 to 1. And so it must have an absolute min and max on this interval from -1 to 1. Remember, that's what the extreme value theorem told us. If you're a continuous function on a closed interval, you have to have an absolute min and an absolute max. So let's go ahead and calculate our derivative. So we would calculate f prime of x is going to be equal to, let's see, I'm going to have to bring down my 4/3. It's going to leave me with 8x to the 1/3 minus x to the -2/3. Okay? I'm going to probably want to simplify this up here, especially when I have these negative powers. Let's go ahead and factor out that negative power, just like we did on the skills check, and think about what power of x we're going to need remaining over here. Well, remember that when I distribute this, my -2/3 power is going to add to this mystery exponent, and it should produce the value of 1/3. So what would the value of my mystery exponent need to be? Well, it could probably just be the value of 1. And then, of course, I can rewrite this one final time as a nice fraction where x to the 2/3 is in the denominator. Again, this is really nice to be able to do because now it's going to be really easy to see when this derivative equals 0 and when it's going to be undefined. So we'll say that f prime of x is equal to 0 when 8x minus 1 is equal to 0. And of course, that happens when x is equal to 1/8. I can add the 1 over, divide by 8. 1/8 is in my interval, so it's a good critical value I'm going to work with. We can also see that f prime of x is undefined whenever x to the 2/3 power is equal to 0. And that, of course, happens when x is the value 0. Again, another good value inside my interval. So now I can start to create a list of all of the candidates that I need. Right now, what I've found are my critical values. And so over here on the next page, I'll start to create my list. So I have all of my potential x candidates. Remember, I'm going to include the endpoints of my interval in here. And I tend to like to write mine in increasing order. You don't have to, though. And then over here, I'll have to compute the function f of x, evaluated, of course, at each of these individual points. So let's take a look here. Ooh, gosh, this is going to be really messy. Doing something like the 1s and the 0 are going to be pretty easy, because 0 is just going to create 0 here. Notice if I plug in something like -1, this is actually going to get me, what is that going to be, 6 minus 3 times -1. So that's going to get me something like the value of 9. You could double check me on this. I'm trying to compute quickly in my head. If I plug in the value of 1, I'm just going to get 6 minus 3, so that's going to be 3. And 1/8, that's going to be a little messy. But if you double check this on a calculator, I think you can get to a value of -9/8. And so Now I know these are the only x values that could possibly create mins and maxes for the graph. And now I can see which one is biggest and which one is smallest. Super simple. So we can state here that f of x has an absolute max of, let's see, 9. 9's the biggest out of all the options. And I also know that that occurs at x equals -1. I can also see that f of x has an absolute minimum of -9/8. And that occurs at x equals an eighth. There it is. And again, you could check to see if this, if what we found here makes sense by taking a look at the actual picture of the function. Now, we trust that the calculus works because we've proved all the ideas up to this point to be able to understand that this idea will work. But sometimes it's helpful to go ahead and look at the function to be able to kind of see and make these connections. And I encourage you to go ahead and do that. In the next video, we'll take a look at example number 9, which is going to ask us for the same idea, but we're going to be working with a complicated trig function as well as this mixture with a polynomial, and have to think carefully here about what is going to be happening in terms of solving some nice trig equations.